This is screencast number 4 for week 4, 571. So I was talking about this Datalyzer software. Actually, they have several software products that are intended to integrate a process failure modes and effects analysis with the out-of-control action plan that's connected to a control chart. The idea is that this linkage will make the failure modes and effects analysis for the process, the manufacturing line, be updated online, and also failure modes will be discovered through experience with the production line. So I'll go into these ideas in a little bit more detail, but right now I want to do a baby example of an out-of-control action plan. So an out-of-control action plan is best shown as a flowchart. And here's an example from what is often used as a group training exercise in a Six Sigma workshop that's run in an industry setting rather than in an academic setting. And the idea is that they have this catapult, and there's a spring, and there's a little cup, and there's a tennis ball. And the idea is to see how repeatable the landing point of the tennis ball is through the how far back you pull the catapult, and whether the spring is new or old. So the metric is the distance from some reference point to where the tennis ball lands. It's a little bit of it's a little similar to the wheel hit of an airplane on an aircraft carrier, but it's a lot less interesting, it seems to me. However, it's something that you can set up in a seminar in a hotel, and a lot of these Six Sigma courses are run by little outfits by having people all fly into a hotel, and then they go to the conference room and they have these workshops. So let's say you're trying to build this, you're trying to run a control chart on this, and you measure a distance, and that distance comes out to be an unreliable measure. So you simply just go ahead and redo the measurement. But let's say the measurement's reliable, so you can't just blame the measuring system. Do you have a range chart signal? Well, if the range chart hasn't given you trouble, then you can go over to X bar bigger than the upper control limit, and slow increase. So you say, yes, that's what happened. Then you are asked to check temperature. to see if it is increasing. If you answer no, then X bar I bigger than upper control limit and new spring. And you answer yes, and you increase spring renewal. Spring renewal time. So what you've done here is you've drawn out a schematic for what you want your operator to do if you have a range chart problem or a signal, and then if you have a an X bar chart signal. And this kind of implies that, like Ryan has mentioned more than once, that you shouldn't be running just an X bar chart. You should also be running an attendant measure of whether or not the variance is in control. And I recommend, and so does Ryan, an S chart over a range chart. But lots of people use range charts out there in the big bad world to monitor variance. So this can get pretty complicated, and operators need to be trained to react in an appropriate way that it's following the steps in this chart. And if you look at what's going on here, really, this is actually troubleshooting. Any good auto mechanic is going to have in their head lots and lots of these flowcharts, depending on what they see as a problem in when a car is brought in that's not working right. So an out-of-control action plan is not anything that's a brand new concept. So it's related to troubleshooting. The difference, though, is an out-of-control action plan can include recalls, messages to specific managers, review of suppliers. So if you have suppliers that have provided material that you suspect that if you do get signal, it may be because of materials, then the OCAP may trigger a review of what the supplier was giving you. So I just want to point out that these are management tasks. So management may become involved in the situation where you have an out of control event. It's a lot like when when the police show up at a house where there's been a domestic disturbance complaint called in, and they show up, and if they find out, as you see on these cop shows all the time, if there are little kids there, then the cops often are required to take the kids out of the house and stick them in foster care, at least temporarily. So their out-of-control action plan involves something which they have to do. They don't have a choice. They can lose their job as being a policeman if they don't say, oh, well, there's some kids here under 5 years old. They have to go to foster care because we've received this domestic disturbance. You know, depending on the situation. Okay. A control plan is the mandated way to run a production process. And it is referred to, and just to give some foreshadowing here, it's referred to as standard work. In the Toyota production system. But we will be spending a lot of time on that downstream of the TPS. So you are in control. So a CP implies in control. So when you hear the phrase control plan, that's not an out-of-control action plan. That's how you are supposed to be operating the business process to begin with. A PFMEA, which I mentioned earlier, is kind of a cool thing, and that is it's an FMEA of the manufacturing process. Well, you know, who's heard of such a thing? Well, actually, if you have a really complicated manufacturing or some sort of production process, anybody who's been on that line for more than a couple of months knows darn well that the line has issues every once in a while, and when it fails, when it goes out of control, there's often a common theme. Maybe you have a system that is super sensitive to the quality of the lubricants, and if the lubricants have just a tiny bit of contamination in them, then say some extremely fine filters fail, and the filters fail, or they have too much pressure, and the other systems fail, and pretty soon the whole thing shut down, and it can all be traced, as people have found out the hard way, back to the quality of the lubricants. Well, that's a failure mode. And the business process is the actual manufacturing line. So a process failure mode and effects analysis says, let's build an FME excuse me, FME way of all the ways a process can fail. So Datalyzer comes along, says link the out-of-control action plan of a control chart, well, triggered by a control chart, to the process failure modes and effects analysis. Well, they aren't the first people to have suggested this. See their white papers on their website. But also see some very smart people in France. And out on my website, they're under the name millie.pdf for the poster session. It's a one-pager. And millie2.pdf. And these guys, a French semiconductor manufacturer. Connects failure modes found during regular maintenance tasks to the tooling process FMEA. So what you're taught in a standard treatment of building a failure modes and effects analysis is you go through all this work to find all these failure modes somehow. Nobody ever really says how. And then once the failure modes and effects analysis is built and you've computed the RPN, you make a nice shiny document, put it in Word and send it to everybody, and it's dutifully filed away somewhere and forgotten. Well, these guys in France said, that's a really bad idea, because then the failure modes effects analysis just becomes this irrelevant thing that you spend a bunch of time on. And weren't you dying to do this for some good reason, i.e., identify failure modes that you need to jump on early? And by the way, where did you get the failure modes? So you use failure modes discovered during the hunt for special causes. That was triggered by a control chart signal. So the control chart, either X bar or S or a range chart, gives you signal, and your out of control action plan says drop the line. So here would be a classic out of control action plan. Signal. That's a start. Drop line. And then I remember the day when at Burroughs Corporation in Westlake Village in 1979, I was at my desk as a newbie engineer, and Jennings comes walking down the hall, and he says, the line's down, Peter, you need to come with me. And Peter Shea was an older engineer who'd been there a while, and he just gets up and follows Jennings. And I asked this other guy, Bill Chow, and I said, well, what's going on? And Bill says, oh, the line's down. That's really bad, Tim. The production line just shut down, and Peter Shea knows a little bit about some of the tooling. And so Jennings, being one of the lead engineers, asked him to come with him to find out what's going on. Well, pretty soon a bunch of the other older engineers all leave, and everybody's out on the production line because everyone's super freaked out that the production line has stopped, because everybody knows that that means that we're bleeding money very quickly. So the line goes down, and what do? Get lots of technical people. Out online. Now, use your best people to search for assignable causes. Now, in a typical setting, you have this fix problem and restart line, and then that's as far as the out of control action plan goes. Datalyzer and these guys in France say, no, that's not what you should do. You should after you get the line back and everybody breathes a sigh of relief, you should see if failure mode is new. If so, update the associated process failure mode and effects analysis. So what does the FAA do actually? It's kind of creepy, but what they do is when there's a terrible airplane crash, lots of people dead, they send people out and they search for assignable causes. Then they write really stern memos to Boeing or Lockheed telling them what they got to fix, and they're done. If you look at the process of flying people around the world in commercial airplanes as a meta business process, if you will, and if it's a new failure mode, they make a TV program out of it. But they also make sure that Boeing never does that again. The risk priority numbers on commercial aircraft, of course, for any failure mode, those risk priority values are somewhere around 900 because the severity is enormous. You know, everybody dead. You know, it's rare to live through a jet aircraft commercial airliner crash. It happens, but it's not very often. So Datalyzer says we have software to do this. So the FMEA is maintained in software, and this automatic updating off of the chart, this is off of a control chart. See, so this connects the control chart to the failure modes and effects analysis. That's crucial. And you're not going to find such a software-based way of linking the two unless you find these little outfits that are providing custom software to do this. This is a great example of where, if you're entrepreneurial, there's lots of places to support business and make money doing it by starting up a software firm. But you've got to know where there's a need. Okay, so where do you get some straight scoop on out-of-control action plans? Well, you can start with reading this paper by Chima and some other authors that I have out on the G drive, and that gives you a lot of discussion about the difference between a control plan and an out-of-control action plan. Datalyzer is not doing something which is proprietary and patent. You can build your own online FMEA database. You know, if you think about it, what is it, an FMEA? It's a database with some computations in it. So anybody who knows anything about SQL, I call it SQL. You know, the E's not in there. I don't know, but whatever. I call it SQL. With the structures suggested in actually now a pretty old paper. Which is also on my G drive, by a guy named Kukul. So it just occurred to me that a possible project that you could do for this course is to read Kugel's paper and see if you can take some business process and develop your own database system for maintaining an FMEA. Of course, you're going to need to link that to the rest of what is needed for the project, but that would be a very useful thing that you could bring away from the course, something which you could very possibly use downstream. End of screencast.